Hi, I am Efma, and in this video I will present our work about learning to ground instructional articles in videos through narrations. This is joint work with Triantafylos Afouras and Lorenzo Torresani at Meta AI. Given an instructional video about a task, as well as an instructional article about the same task, our goal is to identify the relevant temporal segments for each article step, if the step is demonstrated in the video. Grounding article steps in procedural videos poses several challenges. First, models need to be able to comprehend fine-grained step descriptions in context. Another challenge is that some steps might be demonstrated in the video differently from how they are described in the article, or they might be executed in a different order. For example, this person first prepares the dough and then fills the tin with paper cases. Also, the person adds the flour without using a sieve as described in step 4. Training a model for this task becomes even harder, since there are no existing large-scale annotated datasets for it. Therefore, prior work has started looking into weakly supervised article grounding as a way to mitigate the need for temporal annotations of article steps in videos. In particular, Chen et al. Recently collected a curated dataset of videos with known task label and then trained the step grounding model using video instructional article pairs as weak supervision. However, carefully selecting videos limits the number of tasks, and the proposed approach does not leverage the rich information from the narrations of instructional videos. Articles have been leveraged as weak supervision in other works as well, primarily by assigning article steps to short clips for representation learning. This has been shown to outperform the noisy supervision from ASR. However, the steps were assigned based on ASR, and thus they might not be visually aligned with the video clip, and they might be sourced from many articles, loosely related to the video task. To address these limitations, in this work we train with video article pairs that are automatically sourced from uncurated video collections and WikiHow. Video segments are automatically assigned to steps by looking both at the visual content and narrations. We also introduced a model for the task, called VINA, which jointly aligns video with narrations and steps, thus utilizing the ASR transcript for step grounding during inference. This is an overview of our model. It is very simple, consisting of 3 unimodal encoders to model the sequence of frames, the sequence of ASR narrations, and the sequence of steps respectively, as well as a multimodal transformer that models interactions within and across modalities. We ground steps using 2 alternate pathways, directly finding matches between steps and video frames, and indirectly first finding relevant ASR narrations to each step, and then grounding these narrations to the video. We found that fusing these 2 pathways improves performance. We train our model using pseudo-labels. In particular, given a video, we automatically identify a relevant WikiHow article that might describe a slightly different recipe, and then we compute a temporal segment for each article step by using a video-to-text alignment module trained on ASR or our teacher VINA model. Since a lot of the steps are not visually groundable in the videos, we aggressively filter pseudo-labels with a high threshold. To evaluate our approach, we introduce a new benchmark called HT-STEP. We collected article step grounding annotations for 1,200 videos from How to 100 Million. Our test split contains 120 recipes and 1.2K annotated steps. We evaluate models with a recall metric based on a single timestamp prediction. Our model improves up to 90% relatively over our strong baselines on our new benchmark, yielding a significant improvement even without having access to the ASR transcript during inference. When the ASR transcript is also available, we obtain a further improvement. VINA can also tackle video narrations alignment, or in other words, predict when a narration is visually demonstrated in the video. When evaluated on HTM Align, VINA improves by 35% relatively over the current state-of-the-art on narrations alignment, as well as over TAN**, our stronger implementation of TAN with longer temporal context. Finally, we also evaluated our model for zero-shot action localization on crosstask, where we are given a video, its task, and the steps of that task, and we need to find the temporal segments associated with each step. When evaluated with a standard average recall metric, our approach outperforms strong state-of-the-art approaches such as UniVL. Finally, I will show a qualitative result. As we can see, VINA is able to correctly align most of the steps of this tempura recipe, and only confuses the steps add diced tomatoes and adding the greens, which involve the addition of different ingredients. For more details and ablations, visit our poster. Thank you.